Well, we have already started solving equations, but it's a good visual to understand how this works using a flowchart. If you've had a hard time understanding how that works, this should help. So the first thing that's really important is that you don't forget the difference between an equation and an expression. The biggest difference is that an expression can be as simple as one variable by itself, a variable with another number like n plus 2. We could have y squared plus 3y. All of these are expressions. And the thing that separates them from the equation is that there is no equal sign. And you'll even notice in the word equation, you can see the root word equal. Okay, so an equation, of course, would take any one of those and say x equals 4. N plus 2 equals 17. Y squared plus 3y equals 42. Okay? You'll notice that any one of these, x is just by itself. Here we have a variable and a number. They can't go together. I've been talking to a lot of you about if I've got a desk and 2 chairs, we still just have a desk and 2 chairs, even when I add them together. Now this is y squared and a y. You might say, well, those are the same. They're really not, because this one, don't forget, means y times y, which is not the same as a y. Okay, so that's the biggest difference between our expressions and our equations. There is an equal sign with my equations and not with my expressions. Okay, so let's get into what a flowchart really is. A flowchart tells a story. I love stories. Don't we all love stories? Of what happens to the variable in an expression on its way to find the solution and become an equation. That sounds very complicated. Well, let's see. If I've got, say, x plus 4. Well, I start out, I build my flowchart. I know that whatever's going to go in here is going to be x. And then these are my action arrows. That's what we call those, just so you know that those are called action arrows, because they tell you what the action is. Kind of like in a story, what happens, what's the interesting part. So in this one, the thing that happens to x, when I tell the story what happens to it, is that we get to add 4 to it, plus 4, and then we get some other number. So I've set up my flow chart. So now, for instance, if I knew that x was equal to 5, I'd take my flow chart and I would substitute in. Now, let's just follow x right through the flow chart first. I start with x, I add 4 to it, so I end up with x plus 4. That's what the flow chart looks like with my expressions. Now when I put an actual value to the variable, such as x equals 5, I put 5 in here. Remember, this side is my input, and this side is my output. I know that you heard those terms before now. Most certainly in elementary school, 6th grade, any one of those, input, output. So anyway, I start with 5 as my assigned value for x. I add 4 to it, and I get 9. Now these are very simple. We call these one step. All of these are one step. I'll actually write it this way. One, writing kind of sideways, but I'm sure you can still read what I'm writing. These are one-step equations, which is mostly what we're going to be dealing with right now, but I do want you to see some of the two-step equations, so I'll actually write this sideways over here. Two-step equation. Sounds like we're doing a dance. You know how Mrs. De Silva loves to sing and dance in math. But anyway, regardless, let's take a two-step expression, and I would say something like, let's say 3n plus 2. So I know that I'm going to start with n right here. My first action, if I look at n, I remember my order of operations. What's the first thing that happens to n? Is it multiplied by 3 or is 2 added to it? Well, you know your order of operations, and we know that it's the multiplication first. Multiply first, right? So the first action is times 3. Well, I don't know how much of that announcement you heard, but I tried to stop it. Anyway, the first thing that happens to n is that it gets multiplied by 3, and that, of course, makes it 3n. I like to write on the inside of the circle before I circle it so that I make sure I have enough room to write whatever I need to in there. Now, what happens to it next? The very last thing is that we add 2 to it. So, of course, that means I'm going to have 3n plus 2. So there's my flow chart. There's my completed flow chart. 2 steps, you'll see, because I've got 1 step and 2 steps. I do 2 things. So now, let's pretend I say that n equals, I don't know, let's say 7. Okay, so I take that very same flow chart. Now is when I like to set up my flow chart ahead of time. Make sure that I make my circles big enough so that I can write in them. Because the story's already been told. We already know the story of what happens to n. First it's multiplied by 3, then it's added by 2, and then we get some solution. So my input, like I said, is n equals 7. So in the input, I'm going to have 7 times 3. So I know that that's 21, plus 2 more gives me 23. So in this particular case, when I actually write out the equation, which I know I didn't do on the other side, but it's 3n plus 2 equals 23. So that's how we see how an expression right here becomes an equation here. Okay, so a flowchart can also tell the story of how a solution was found. So remember, the solution was the output by backtracking through the flowchart to find the original value or that original variable. And this is where we always ask that question, what's the opposite? I know we've already started doing that, and we keep asking it over and over again until the original value of that variable has been found. So, for instance, if I have that, we'll start with the 1 steps, and if I've got, say, x minus 8 equals 5. The first thing I'm going to do is set up my flowchart. What's the story of x? Well, here's x. What's the first thing that happens to it? First thing that happens to it is that I subtract 8, and that gives me x minus 8. And that's what I started with. There it is. There's my expression. Well, now I know that x minus 8 is equal to 5. So I'm going to line up these circles right underneath. But this time, I know that I'm going in reverse. So remember, x minus 8, we now know equals 5. So in here, I'm going to put 5. And I'm going in reverse. So I say, what's the opposite of minus 8? The opposite of minus is plus. The opposite of minus 8 is plus 8. 5 plus 8 is 13. So I now know, see how this goes down to here, that therefore x equals 13. Well, that makes things easy, don't you think? Let's try one of those 2-step ones. Again, we're reaching into the 2 steps because I want you to see them, but we're mostly going to be focusing on these 1-step equations right now. So let's see, if I had, let's say, actually, let's make it hard. It's really not hard, but x divided by 5 minus 2 equals x divided by minus 2, let's do 3. Okay, so first we have to tell the story of x. So here's x. What's the first thing that happens to x? It's divided by 5. So the first part of the story of what happens to x is that it's divided by 5. This is the only place it's really appropriate to write that old division sign that you've been writing for so long. Remember, we always divide with a fraction bar now. So x divided by 5, gives me, of course, x divided by 5, because I'm still just dealing with the variables and the expressions. The next thing that happens to it is that we subtract 2, minus 2. So that, of course, gives us x divided by 5 minus 2. And that is the expression. That's what we have right here. So now we know that 3 is the output. So I'm going to set up my flowchart. I know that there's 3 bubbles or circles. I know I'm going to be reversing it out, so I know that this whole thing right here is equal to 3. So my output is 3. I ask myself that question: what is the opposite of minus 2? Because I'm going in reverse. I'm backtracking. The opposite of minus 2 is plus 2. So 3 plus 2 is 5. I ask again, what's the opposite? What's the opposite of divide by 5? It's times 5. 5 times 5 is 25. So I now know that x equals 25. Okay, so these are the things that I want to remember. A flow chart is used to find the solution to an expression after a value has been assigned to the variable by going forward. Remember, that's when we went forward through the flow chart. And then we can also find the original value of that variable by backtracking. Now you're going to get some practice working with those flow charts going forward from here.